Hi, a warm welcome to you. In the last video we have seen remainder theorem as part of polynomials. So let's try to get a recap of that, then we'll move to the factor theorem. The remainder theorem states that if p of x, a polynomial in x is divided by x minus a, then the remainder is nothing but equal to p of a. How we have proven that? I am just trying to give a recap to you. Suppose we say polynomial of x is nothing but equal to x minus a. Since you are trying to divide it, it should have some quotient like 14 equal to, like what we are saying, 14 equal to, if you are dividing by 4, that's nothing but equal to some quotient 3 plus some remainder 2 here. This is nothing but equal to x minus a into q of x plus remainder here, which I don't know. Now, the remainder theorem says that this remainder is nothing but equal to p of a if you are trying to divide the polynomial by x minus a. Let's have a look at that. Now, suppose if I substitute the value of x equal to a, this becomes p of a equal to a minus a into q of x plus remainder. Now you know that this whole thing becomes 0 because a minus 0, 0, 0 multiplied by anything is 0. So that gives you p of a is equal to remainder, or remainder is equal to p of a. We have also taken one example. We have also taken couple of examples to see that how we are able to prove that the remainder theorem is working out well. So let's just look at what happens from the remainder theorem. The next step is factor theorem. Factor theorem states that if p of x is divided by x minus a and x minus a is a factor of p of x, then remainder should be 0. That means p of a equal to 0. Or if remainder is 0 or if p of a is 0, then x minus a is a factor of the polynomial p of x. So let's try to understand. Now what happens? Now what happens if this part becomes 0? If this part becomes 0, I will have p of x equal to x minus a into q of x. You can see from our basic definition of multiplier and factor that x minus a is a factor of p of x. This linear polynomial is a factor of the polynomial p of x because the remainder is 0 here. So the theorem states if p of x is a polynomial of degree n greater than or equal to 1 and a is any real number, then x minus a is a factor of p of x if p of a is equal to 0. If p of a is equal to 0, and also p of a will become 0 if x minus a is factor. What's the meaning of that? If I write p of x is equal to x minus a, I know that x minus a is a factor of p of x. That means I'll have some value g of x. When it becomes factor, the remainder will be nothing but 0 because it is called as factor only when the remainder is 0. Now the value of x value a, which makes x minus a as a factor, is also called as a is known as 0 of the polynomial or root of the polynomial. 0 or root of the polynomial, ROOT, root of the polynomial p of x. So the factor and the 0 are closely related. If x minus a is factor of polynomial, then a is called as x minus a is factor, then a is called as 0 or root of the polynomial. Now let's try take a simple example and try to using factorization theorem try to find out the factors. So let me take a simple example. Let's take a simple example. Let me say that x square minus 3x plus 2 is the polynomial given to us. We have to find out factors of this by using factorization theorem. Now our input here is, if p of a is equal to 0, that implies that x minus a is a factor and a is also root or 0 of the polynomial. So let us see for the values of which values of x this polynomial will become 0. If I look here, if I see all positive coefficients, if I add them, 1 plus 2 equal to 3, and all negative, there is only 1 minus 3. 3 minus 3 is 0. So I know that if I substitute 1, I should get 0. So I will say p of 1 is equal to 1 square minus 3 into 1 plus 2, that is nothing but equal to 0. Immediately you know that x minus 1 is a factor of x minus 1 is a factor. Similarly, let us check for p of minus 1. If I substitute minus 1 in the polynomial x square minus 3x plus 2, this becomes minus 1 whole square minus 3 into minus 1 plus 2, that is nothing but 1 plus 3 plus 2 equal to 6, which is not equal to 0. So x plus 1 is not a factor. X plus 1 is not a factor. Now let's look for x equal to 2. That means let us look for p of 2. If I check for p of 2, 2 square minus 3 into 2 plus 2, that is nothing but 4 minus 6 plus 2, that is nothing but 0. So I know that x minus 2 is a factor of the polynomial. Since the degree of the polynomial is 2, there will be only 2 factors. Remember that always, how the degree of the polynomial decides how many zeros it will have. Cubic polynomial will have 3 zeros or 3 roots, whereas quadratic polynomial, what you see now, ax square plus bx plus c format, will have only 2 factors. So the factors is nothing but equal to, as we have learned, they are, one is x minus 1, another one is x minus 2. So I can write x square minus 3x plus 2 as x minus 1 into x minus 2. Let's take another example. Let me just recap this, what we have done. We have been given a polynomial and we have been asked to factorize this polynomial. I know that if I am able to find out the value of x which makes the polynomial 0, then x minus that value will become a factor. So I checked for x equal to 1. I found that the p of 1 equal to 0. According to the factor theorem, if p of 1 equal to 0, then x minus 1 is a factor of the polynomial. Similarly, I checked for p of 2. P of 2 turns out to be 0. That means x minus 2 is also a factor of the polynomial. Now, since the degree of the polynomial is only 2, you will have only 2 zeros or two zeros. That means the factors will be, you can only factor them into 2 irreducible factors. That means you cannot reduce them further. Like we do factors as prime factorization, this is also irreducible. I cannot reduce further from here. Now let's take another example and see how to do one more problem using the factor theorem. I have been given that x plus 1, I have been given that x plus 1 is a factor of, x plus 1 is a factor of x square minus 2x minus k. Find the value of k. Find the value of k. So, if you look to the factor theorem states that if x plus 1 is a factor, then what is the, let's try to convert this into x minus a. X plus 1, I can write it as x minus of minus 1. Another way you can do is, you can equate this to 0, x plus 1 equal to 0. That gives you x equal to minus 1, or I can write x minus of minus 1, which is nothing but in the form of x minus a. So a equal to minus 1. I should have p of a equal to 0 because x minus a is given as factor of this. Now my a value is equal to minus 1. If I substitute that, p of minus 1 is equal to minus 1 whole square minus 2 into minus 1 minus k. That's nothing but 1 plus 2 minus k equal to 0. We know that, so k equal to 3. Let me repeat that again. Given that x plus 1 is a factor of x square minus 2x minus k, find the value of k. We know that if x plus 1 is a factor of this polynomial, then x value of minus 1 will also be a 0 of this polynomial. If it is a 0, then p of that value minus 1 should be equal to 0. Because we know that remainder is 0, we know that remainder equal to 0 when a number is divided exactly. So we have substituted that, we found the value as k equal to 3. Now let's do one more example. Let's take a cubic polynomial where we will have 3 roots. With that we will close this video, and in the next video we will see how to find out the zeros using different methods. Not only the factorization theorem, splitting the middle terms, using the graphs, and also completing the squares. So let's take another example. The example here is, the polynomial is given by x cube plus 3x square plus 32x plus 20. Now we have to find out the factors of this. Now if I look here, if I try to check, I see that all of them are having the same sign. So to get 0 or the value of x which will make this polynomial as 0, I know that I have to go for negative values. Remember that if you have plus and minus, then there is a chance that one will satisfy it. If there are all plus, then always you have to check for the negative values, because then only you can cancel them out. So let us check for the first value, p of minus 1. If I substitute minus 1 whole cube plus 3 into minus 1 whole square plus 32 into minus 1 plus 20. This is nothing but equal to minus 1 plus 3 plus 32 minus 32 minus 32. Let me just erase that. We have minus 1 plus 13 minus 32 plus 20. So you can see here minus 33 plus 33 equal to 0. So the polynomial is x cube plus 13x square plus 32x plus 20, and we have substituted value of minus 1. Because we have seen all of them are positive, only negative values should come to our rescue. Because if I put any positive value, this becomes more and more positive value. So I have checked for negative value starting with minus 1. Earlier it is 3, I have rectified that, this is 13 now, if you can observe that. So this is nothing but, if I put of minus 1, I see that p of a is equal to 0. I know that if p of a equal to 0, then x minus 1 is a factor. x minus a is a factor, sorry. If p of a is 0, then I know that x minus a is factor. That means x minus of minus 1 is a factor, which is nothing but x plus 1 is one factor. So I know that x plus 1 is one factor. I need to get two more because it's a cubic polynomial. I should have three factors, irreducible. Right. Now what I will do is I will try to simplify this and see if I can get x plus 1 as common from here. So what I will do now is I will write this as x cube. So if I divide by x square into x is x cube. So I should have one more x square, so that I can take x square common, then I will have x square into x plus 1. So what is left out to me out of this 13x square is now 12x square. Now if I have 12x square, if I want to take x plus 1 common, x into 12x, so I should have another 12x here. I am left with 32 minus 12 is 20, x plus 20. Now what we have done simply is we have rephrased this in such a way that we can take x plus 1 as common, because we know already that x plus 1 is one factor. Now here I can take x square as common, it becomes x plus 1. Again I can take 12x as common, I will get x plus 1. Plus I can take 20 as common, I will get x plus 1. So this is nothing but equal to x plus 1 into x square plus 12x plus 20. Now we have reached up to one stage. Now we have to go further. We have found one factor. Now I have to take this and find it out. I look at only this part, that is x square plus 12x plus 20. As I said earlier, if all the terms coefficients are positive, then you have to go for the negative values. So let's try for x equal to minus 1. That is nothing but p of minus 1. If I go for it, I get 1 plus 12 into minus 1 plus 20, which is nothing but equal to 21 minus 12 is 9, which is not equal to 0. So x plus 1 is not a factor. Let us go for x equal to minus 2. If I go for x equal to minus 2, p of minus 2 is nothing but equal to x square, that is minus 2 whole square, plus 12 into x value is minus 2 plus 20. This is nothing but equal to 24 minus 24, that's equal to 0. So that gives me that x minus of minus 2 is a factor, or x plus 2 is a factor. So I can write this as x plus 1 into x plus 2 into, if you see here, the coefficient of x cube is 1, so I will have only x here. And you see here, the term is 20. That means I have 1 2s are 2, 2 10s are 20. I will have 10 here. You can ask me why you haven't went for minus 10, because you don't see any negative terms. All are positive. Since all of them are positive, every term is positive, so I should have x plus 10. So the factorization of x cube plus 13x square plus 32x plus 20 is nothing but equal to x plus 1 into x plus 2 into x plus 10. We have used the factorization theorem and we have got it. So in the next video we will see how to find out the zeros, or other way of saying that how to find out the factors of a polynomial in different methods. Thanks for visiting. Bye for now.